whenever I usually get a piece of malware, the first thing that I do, I built out this PE parser in PowerShell called PowerParse. There's a lot of PE parsers out there that are great. I know Matt Graber has created one as well. But there are just a couple of things that I always like to do initial triage of some malware. And that's what I built into PowerParse. So I ran PowerParse against this. And some interesting things that kind of point out here is that this is a exe binary. It's a 64-bit binary as well. There's only one PE in this. This is kind of important. There's a lot of malware out there that will like embed multiple PEs and then separate itself upon execution. So that is built in for this as well, which I found pretty interesting. And then lastly, it will pull the TTPs or the techniques that are used. This is based off of a list of APIs that I know that correlate with specific techniques. And so if you look at this next slide here, we can see kind of the different TTPs that were executed. And there's some interesting aspects here. Like it creates a process somewhere, and it also will open a process, read some memory. Now, it doesn't mean that this is dumping LSASS directly, but it just means that these API calls are somewhere within this binary. And there was an attempt, like in PowerParse, an attempt to kind of match those up with techniques that kind of matter. There's obviously is debugger present. That's common within malware. They just want to make sure they're not being debugged, and they'll kill off if they are. There's some Cobalt Strike and like command and control APIs in here, which I found quite interesting as well. And then there's some ETW patch APIs, which we will dive into here in a little bit. Again, PowerParse was simply meant to just kind of get an understanding or lay of the land of like what techniques are the malware is doing. This is nice for ransomware or non-ransomware malware. That way, whenever you are jumping into the malware, you kind of have a place to start. You can always start at the main function, which we'll do here in a moment, or you can just dive into the techniques that are actually being deployed and kind of see what it's doing there.
So Johnny, just before we move on, do you want to just talk quickly about why those Cobalt Strike APIs were so weird in this particular case, in the sense that they,
Yeah, we won't dive into it too much later, so it's a good point to bring up now. What's interesting here is that there was a structure that had these strings in it, these beacon function strings, and it point to a function where it was implemented. Like there was some stuff for like revert to self. That's common with like token impersonation, things like that. What's interesting with there is that you'll commonly see that with like obviously beacon shellcode or like generated stuff like that. But this was more embedded within this. So like you won't commonly see that within like a larger ransomware malware where it's embedded and then implemented. What's interesting too is that we found no indication that these functions were ever actually called. They were in the structure. You could see that. You could see some of the functions were implemented, but there were never actually any calls to these functions. We didn't necessarily dive into from a debugging perspective to validate that fully. But just inside of, Binary Ninja or IDA, there was no cross references to that structure or that table and none to those functions directly. Did you want to add anything else to that, Alden?
Yeah, I mean, I think that kind of highlights a general trend with this ransomware is that there's a lot of functionality that's included but never used.
Yeah.
So whether or not that's an indication that this is obviously a young threat group that is sort of starting out in ransomware, so maybe they're just sort of testing out different functionality to see what works and what's not good. It's quite strange, but it's definitely interesting to note. So there's some functionality that you'll see that we'll talk through that maybe, I think everything that we talk about today is used, but there is a bunch of other stuff that is included that is malicious and interesting. But given that it wasn't used and we couldn't see any like even indirect references to it, it's not super important.
There's also some functionality in here that's like not complete functions were thought through. Like we'll talk about ETW patching here in a little bit, but some of the functions, there's like one particular one that where they did everything you would need for patching except the patch itself, which was interesting. We found some of like incomplete functions within this malware ransomware variant as well, which was interesting to see. You don't really see that quite often.